Welcome everybody to today's lesson on some more identities. We're going to talk about identities that involve the sum of trigonometric functions, okay? So normally I write this out as we go, but because these are just so long, it would be boring watching me write. I've written some of this out ahead of time, and we'll just slide the paper and uncover the work as we go. So in dealing with the first set of 8 that we're going to talk about in this lesson, we have the product to sum identities. So we're talking about products of different trig functions with different angles, okay? Now notice the format here. They all have 1/2 and then some sum difference of the various trig sine cosine functions with a sum or difference of the two angles alpha and beta, okay? Now, it's impossible to remember all of these formulas that we've been introducing in this unit, so it's important to study it from a format perspective so you can recognize a possible relation later on and say, oh, I know there's a formula I can use for that. I just have to go find it. And many of our books just have tables of these various identities that have already been figured out. So what I want to do is I want to take this cosine alpha, cosine beta identity and show you how it was derived. And when I look at this one, the last time I worked with cosine on two angles, it happened to be where I was talking about the difference of an angle or the sum of an angle. Because look over in these formulas. See how I've got cosine alpha, cosine beta, cosine alpha, cosine beta. So I've got this already embedded into another identity. Okay, so I've written each of these completely out. And then what we do here is we just add those two identities together just to see what we're going to get. And the reason we added is because we noticed over here I have sine alpha and beta with opposite signs. So when I add these two together, these two are going to subtract out, aren't they? And that's a good thing. The more we can eliminate, the more simple, more readable, usable our identities are going to become. So I add these two together. So I'm going to have on this side the cosine of alpha plus the alpha minus beta plus the cosine of alpha plus beta, just these two added together. This subtracts out, and these are the same, so I'm going to get 2 cos alpha, cos beta, right? Now, what they did to finish up their identity was they divided both sides by 2 here so that I ended up in the format that you see up above where I have 1/2 cosine of alpha minus beta plus cosine of alpha plus beta is equal to cosine alpha plus cosine beta, okay? So that's one way to go about solving for that. Let's talk about an example here, okay? So what if I ask you to verify this identity, okay? Cosine 2x times the sine of 5x is 1/2 sine 7x plus sine 3x. Well, I look back at my table for a cosine sine. Where do I see a cosine and a sine? Well, isn't that the same thing as this? They're just maybe reversed. So, or I'm sorry, it's right there in front of me, isn't it? Cosine alpha, sine beta, cosine sine. So all I have to do here is pick a side, and I'm going to pick this side this time. And I'm going to have to recognize that alpha is my 2x and beta is my 5x, okay? So now I can plug directly into this formula, and let's see what happens. So I'm going to have 1/2 of alpha plus beta times the sine, alpha plus beta, minus the sine of the difference of the two angles. This minus the sine of the difference of the two angles. And that's going to give me 1/2 of sine 7x minus the sine of negative 3x. See, we're expecting to maybe be done here, but notice I have plus sine 3x, and down here I have minus sine minus 3x. Now, you might be tempted to just factor out that negative, but you can't do that because you're actually taking the trig function of this negative angle. And remember, this is rotating on my unit circle, but this time I'm rotating this way, aren't I? With this minus 3x. And isn't the sign negative down here? So we have an identity that we discussed a while back where the sine of minus an angle is minus the sine of that angle, right? Because if I were to rotate this way with a positive angle, my sine is positive, so I would just negate it in order to get the sine of this angle, right? So I can substitute this sine of minus 3x with just this minus, and it's this minus that's multiplied by this minus to make it a plus. Not this one, but this one. And now I have actually gone through and verified that identity, okay? So that walks us through the first of the four identities we're going to work on in this unit. The other four are these sum-to-product identities, okay? And they all have just sine and cosine, and we're talking about some addition or subtraction because, you know, plus and minus is negative, but it's still a sum. And notice how these sums become products, okay? So it's important to identify the two different angles, and notice we have a sum and a difference, and then we have these products in here. And then from a pattern recognition standpoint, this last one actually has this negative. So make sure if you've got cosine x minus sine x, you were pulling this minus 2 out instead of a positive 2. Okay, so let's look at a problem here. So what if I have the problem write sine 4 theta minus sine theta as a product, okay? So I look up here for something that's similar, and well, here it is. I have a sine angle minus a sine angle. So I just need to go in and identify this x and y, right? So x becomes 4 theta and y becomes theta. Once I've identified that, I just have to go through and plug these things in. So I'm going to have a cosine 4 theta plus theta all over 2 times the sine of 4 theta minus theta over 2. All right, so I want to simplify those. And that's going to give me a 5 theta and a 3 theta. And the temptation here is to maybe try to cancel that 2 out. But you remember, we're talking about the cosine of half an angle. This is double that cosine value. So you have to treat this coefficient separate from all of the work that you're doing inside of here, okay? So that's one way of using these sum-to-product identities. Now, I want to do one more problem for you, and it's going to use maybe some of these, but we'll have to figure out which ones to use. So if I'm looking at a problem, sine of 105 degrees times the cosine of 15 degrees. And I want to find the value without using a calculator, okay? So that means I'm thinking about that good old unit circle, right? So here's a product. So let's go back and think about maybe what does this look like, okay? So here it looks like this one right here, sine alpha, cosine beta, okay? So I'm going to identify alpha as 105 and beta as 15. I better get my degrees. And if you'll walk through me with this, because these two angles aren't on the unit circle, but maybe by using this identity, I can pull some values from the unit circle. So let's write this down. So I'm going to have the sine of 105 times the cosine of 15 is going to be equal to 1/2 the sine of alpha plus beta. All right, so 105 degrees plus 15 degrees plus the sine of alpha minus beta, 105 degrees minus 15 degrees. So let's go through and simplify that now. So I'm going to have 1/2 the sine of 105 plus 15 is 120 degrees, plus the sine of 105 minus 15 degrees is going to give me the sine of 90 degrees, won't it? And now all I have to do is, well, let's see. I have 1/2. What is the sine of 120 degrees? So that's 30 degrees past vertical on the unit circle. It's going to be in the second quadrant. It's going to be a positive sine value. So I should have radical 3/2, shouldn't I? Well, then I'm going to add the sine of 90 degrees. Well, what's the sine of 90? Well, that's one of those that's kind of hard to forget. And that's going to be just 1, isn't it? So I'm going to have to now do some simplifying. I'll have 1/2 radical 3/2. What's 1? 1 is 2/2, isn't it? So I'll have 1/2 of radical 3 plus 2/2. And then I distribute my 1/2 to get radical 3 plus 2 all over 4. So I'm able to take the product of two different trig functions with two different angle measurements that aren't on the unit circle and convert them into something up here that I can now relate with this product to sum formula to actually get a value, okay? So what did we talk about today? Well, we talked about product to sum identities and those formulas, how they relate, how they were derived, and how we can use them. And then we also talked about these sum-to-product identities and how we might use them. Again, the important thing is not trying to memorize them, but to recognize these patterns so that when you do encounter something, you more quickly go to the source of what to use in order to solve that. Okay, so I hope this was helpful, and I will see you next lesson.